So, 3i Atlas, is it a comet or is it alien technology? We're about to hear from Professor Avi Loeb, a theoretical physicist from Harvard University, who believes it does show signs of being made by aliens. But he's in a battle with the broader space community, including Professor Brian Cox, who thinks he's talking drivel. Now, we'll hear from Avi in just a moment, but first, here's what we know so far about 3i Atlas. It's the size of central London and moving at 210,000 kilometres per hour. Scientists first spotted it back in July. 3i stands for Third Interstellar Object. It's only the third object to come from outside our solar system, and Atlas comes from the telescope system that discovered it, the Asteroid Terrestrial Last Alert System. The chain of telescopes are in Hawaii, South Africa and Chile. It was the one in Chile that spotted 3i Atlas. If 3i Atlas hits the Earth, it would wipe out all life on our planet. But thankfully, it's not heading anywhere near us. In fact, it's not a risk at all, unless of course it's an alien space probe, and then we might just be in big trouble. Professor Avi Loeb, thank you so much for being with us. This is your second time on Nexus, and I'd like to start with a pretty hard question, a fundamental one. What makes you think it might be alien technology?
Well, thanks for having me. My basic point is that when we have a visitor to our backyard, we should collect as much data as possible to figure out its nature. This kind of a situation is very different than scientists often address. If we consider a galaxy at the edge of the universe, billions of light years away, there are no implications to society that will change our life in the immediate future. But in case of an object that has some anomalies, we really need to clarify the nature of the object before we can relax.
So let's get to these anomalies then. What are they?
Well, the first one that became obvious to me as soon as it was discovered is that it's a very big object, comparable to the size of a city. Initially, just its brightness implied a diameter of 20 kilometers if we're seeing the reflection of sunlight from a solid surface. And we haven't gotten a very robust constraint on its size until recently, when I analyzed together with two colleagues 4,000 data points regarding its motion in the sky. And the Webb telescope implied that it's losing 150 kilograms per second when it was 4 times the Earth-Sun separation from the sun. So it was at a large distance. And we calculated that in order for it not to have any recoil from this mass loss towards the sun, from the sun-facing side, it must have a mass of at least 33 billion tons. And that is at least 1 million times more than the mass of the first interstellar object, oumuamua. And so the question arises as to why haven't we seen 1 million small ones before seeing such a giant object if it's a rock? Moreover, there is not enough material in interstellar space to deliver such a giant rock, icy rock, to the inner solar system once per decade. That's the duration of our survey. A simple estimate implies once per 10,000 years or longer. So that was the first puzzle, the first anomaly. How do you accommodate the mass budget from the Milky Way of rocks with the fact that we witnessed such a giant rock in our neighborhood over the past decade? The second was that its trajectory was aligned with the plane of the planets around the sun to within 5 degrees. And the chance of that happening at random is 1 in 500. So why would the third object from interstellar space be aligned so well with the planets unless its trajectory was designed by some intelligence for a reconnaissance mission? And then there was nickel being shed from it with very little iron. That's a great puzzle because we've never seen it before, except for industrial production of nickel alloys that are used for aerospace applications. And then there was this antitail that it exhibited during July and August, meaning a glow extended from the object towards the sun rather than away from the sun, the way we see in cometary tails. And most recently, just a week ago, it came closest to the sun. That was on October 29th. And it brightens by a factor of 5, and moreover, it also deviated from its path. And I calculated that it should have lost about 15% of its mass in order to deviate that much. It's just momentum conservation. So I have a prediction for the coming weeks. It will get closest to Earth on December 19th, 2025, just 6 days before Christmas. Let's hope it will not deliver any unwanted gifts to us here on Earth. But the point of the matter is that the brightening that it exhibited near the sun and the most recent images that were obtained after that imply that there are very long range jets coming out of it that go out to 1,000,000 kilometers away from it, both in the direction of the sun and away from the sun. And I just calculated that the amount of mass carried by these jets is 5 billion tons. If it is a natural comet, and when you calculate how much energy is needed to power these jets out of the sublimation of carbon dioxide, which is the easiest ice to vaporize, to sublimate by sunlight, you find that the object needs to have a diameter of at least 23 kilometers, so quite large, larger than the asteroid that killed the dinosaur 66 million years ago. Now, that is 4 times bigger than the limit obtained from the Hubble Space Telescope when it was observed back in July. And so all of this is under the assumption that it's a natural comet. So my conclusion is that either this object broke up into tens of pieces so that it was ablated much more quickly and had a much larger surface area than the original object, or it's something else. And it's easy to figure it out with future observations. So I'm saying let's just wait for this data, and then it will become clear what the object is. If it's a natural comet, not only that it broke up, but we can figure out its composition because we're looking into the body of the object being vaporized. If, on the other hand, it was propelled by thrusters that are technological, and they are the origin of these jets that we see, very well collimated jets. There are at least 7 of them. If that's technological in origin, then of course the ejection speed, the exhaust speed of those thrusters could be far greater than the sound speed of the exhaust gas and of just sublimated volatiles from the surface of natural comets. So the point is that there would be much less mass being lost if we are dealing with technology as compared to a natural origin. And the coming weeks will give us the verdict conclusively.
Professor Loeb, will get into some of the reasons, the anomalies, a little bit more in depth in a moment. But before we do that, just let's skip over all of that difficult stuff and get to what kind of technology you think it could be.
Well, when dealing with a blind date of interstellar proportions, I prefer not to have an opinion or assume anything. The best advice I have for people who go on blind dates is to observe the other side, because the imagination of even script writers in Hollywood is not as developed as what might lie beyond the solar system. So we should learn. It's a learning experience. And even if it ends up being a rock, an icy rock, it would be very different than the comets that we are familiar with in the solar system.
Did you once say that it was potentially a relic from a probe that was sent out by an alien life form a very long time ago?
Well, we don't know how long it was traveling. One thing we know is that it's very big, at least 2 orders of magnitude bigger than our largest rocket, the Starship. And with our current technologies, there is no way for us to lift an object the size of a city to space, let alone give it a velocity of 60 kilometers per second. And so I prefer not to imagine anything, but just observe it and learn from it.
Okay, let's take a look at your observations now. And some of the evidence you put forward includes, as you've mentioned many times, its sheer size. Now, for me, that might argue or be used as an argument against it being technology, because what kind of a civilization could make technology that weighs as much as you say it does and many, many kilometers wide? Surely the sheer size of it would be used in an argument to say that it isn't technology, it's a natural phenomena.
Well, Arthur C. Clarke would not agree with you because in his novel, science fiction novel, Rendezvous with Rama, he imagined a spacecraft cylindrical in shape that is tens of kilometers in size. You have to keep in mind that our science and technology was developed over the past century, actually throughout my career, which spans 50 years. I lived through half of modern science, modern physics, and just imagine a civilization that has been around, developed its science and technology for 1,000,000 years or for 1 billion years. Most stars formed billions of years before the sun. The sun is a late bloomer. It came around in the last 1/3 of cosmic history. And it takes less than 1 billion years for the Voyager spacecraft to cross the Milky Way disk. So there was plenty of time for advanced technologies that are far more advanced than we are to reach our backyard. And the best way to find out about them is to observe these interstellar visitors that will now be seen every few months with the Rubin Observatory in Chile.
Okay, and then the other thing you mentioned was the movement, the cometary tail, which would trail the movement of the comet or the object, and then suddenly it moves from being behind it to in front of it, which I guess would suggest it's changed direction or slowed in some way, and that would involve an ability for it to act against a gravitational pull. In other words, it has its own propulsion system. Have I understood you correctly?
Yeah, in principle, if it's technological, it needs to have power supply for such a big object. And what we are seeing right now, after it passed close to the sun, is a network of at least 7 jets, well collimated jets coming out of it. This is very recent, over the past few days. And of course, future data will give us a much better sense of the speed, the outflow speed along these jets, the mass flux of these jets, and the composition of these jets. With the spectroscopy, we can infer all of that. And that would be fascinating because we can easily tell the difference between the speed of volatiles that are being vaporized and on the surface of just from the ice pockets on a natural object. They should have a characteristic speed, sound speed of 400 meters per second, whereas technology can produce speeds that are at least 1 to 2 orders of magnitude larger than that. This is human-made technologies that we are currently using, either rockets or ion thrusters. But alien technology can bring even higher speeds. So if we figure out that the jets are moving faster than a kilometer per second, that would potentially imply technology.
Let me get to the slightly gossipy part of this story now. People like Neil deGrasse Tyson and Professor Brian Cox, him in particular, have disagreed with you. Brian Cox said you're talking drivel. Which of you should the public trust? Those popular scientists or yourself?
Well, the public should just follow what the data shows us, the images, the spectra that are obtained. And I'm in the trenches. I wrote 12 scientific papers on 3i Atlas. Those commentators that have an opinion, they are just sitting on the bench. They are not part of the scientific process of figuring this thing out. And my basic point is that the foundation of science is curiosity and humility to learn, rather than the arrogance of expertise that is often displayed by experts and commentators. So the public very much resonates with my view because I have more than 100,000 followers on medium.com for the routine updates that I provide. And there is a huge interest in the scientific process where we admit that we don't know the answer in advance. We are trying to figure it out based on data. This is the scientific process and it's a learning experience. And we might be wrong. We might take some risks and say maybe it's technology and then find out that it's actually a natural comet, or vice versa. But we should be open-minded, because if we assume we know the answer in advance, we would not learn anything new.
Just explain, Professor Loeb, the difference between you and the job you do and the kinds of jobs they do and the deficiencies they have.
Right. So my primary job is to figure out what lies outside the solar system. I'm doing the research. I have students and postdocs, wrote more than 1,000 scientific papers and 9 books about science. But the communication of science is just to get the public involved and appreciate the process of learning. Whereas there are professional influencers and commentators that are not really doing any scientific research. They're just trying to be liked and popular by communicating to the public what other scientists are doing. That's the work of Neil deGrasse Tyson or Brian Cox. And I'm quite different than them. I don't need any footprint on social media. I communicate because I believe the public deserves to know that science is a work in progress. It's not what you see in press conferences where scientists tell the public what they should know, rather than regard it as a detective story where we can all be involved as we unravel the truth based on the clues that we find.
Professor Loeb, in your long and celebrated career, what is the most compelling evidence that you've ever found, discovered, of alien life?
Well, so far we don't have conclusive evidence, but 2 out of the 3 interstellar objects, oumuamua and 3I Atlas, the first and the third, appear to be anomalous. It means that we are missing something about the interstellar space, and it's possible that 1 or the 2 of them were technological, because we launched a lot of spacecraft, 5 of which will exit the solar system, and therefore it would be arrogant of us to assume that we are the only intelligent civilization that did that since the Big Bang. And my guess is, as soon as we figure out with future data that indeed there is traffic of technological devices through our solar system, it will change everything. It will change our religious beliefs, our perspective on our place in the universe, as well as the concern about any potential threat from alien technology to Earth that would convince us to invest perhaps even $1 trillion a year, comparable to the military budgets worldwide, in defending the Earth against any such risk.
Well, that's a really good point. Every time I read about you, it's always Professor Avi Loeb warns that if alien life does come here, we ought to be very afraid. On the balance of probability, should we welcome them? They come in peace, or we should be very afraid?
It's very important to be optimistic, because life is sometimes a self-fulfilling prophecy. But we should also have some concerns, because when you go on a blind date, you should make sure that on the other side, the dating partner is not a serial killer.
Okay, that's a very good point. And a great analogy that I think a lot of people can relate to. You have speculated in the past that human beings may come from Mars. What makes you think that?
Well, Mars cooled before the Earth. It's a smaller body, and it may have developed life before Earth did, because Mars had rivers, lakes, oceans of water on it, and an atmosphere until 2.5 billion years ago. So throughout the first half of its life, it had life, and rocks could have delivered it to Earth, so we might all be Martians. And as we go back to Mars, it may be like going back to our childhood home.
So sort of a return journey. You mentioned rocks may have come from Mars, bringing us here. How would that have happened?
Well, we've discovered a rock about 45 years ago that was not heated by up to more than 40 degrees Celsius since the time it was ejected from Mars and arrived to Earth. And that means that in principle, microbes could have survived in it. And that illustrates the possibility of microbes being delivered to Earth from Mars.
Professor Loeb, a final question for you. Most scientists agree that the Earth is billions of years old. Is it possible that another entire civilization, perhaps even a high-achieving one, existed and all the evidence was wiped out, and it existed billions of years ago?
That's possible. Recorded human history is only 8,000 years old, and that's one part in 1,000 of the history of life on Earth. And it's quite possible that hundreds of millions of years, intelligent life already was developed and then wiped out by some disastrous event, catastrophic event. We have no record on that, and the record could have been mixed with the interior of the Earth through geological activity, through asteroid impacts. And it would be obviously interesting to check, for example, on Mars or the Moon, if there is any evidence for previous civilizations, because they are like museums. They preserve what was there over the past few billion years. And so we should leave this question open to further evidence.
Okay, Professor Loeb, are you a tenured professor at Harvard?
Yes, I have been tenured for 25 years at
And is
Harvard
this
University.
why, and would you describe yourself as an outlier amongst the space and science community?
I have been tenured since 1997, so that's quite a long period of time, 28 years. And the reason I look different than many of my colleagues is because I was initially interested in philosophy, in the big picture, in the most important and consequential questions. And I'm very glad to have the fortune of pursuing them through the scientific method. But many of my colleagues concentrate of technical questions. They drill down with mathematical virtuosity. I think it's important not only to have people who put the bricks on top of each other in making the construction of science, but also to have architects who define what are we trying to build? What are the most important questions that we would like to answer?
But do you feel pressure on you to fall in line and to meet with the consensus?
I've been chair of the Harvard Astronomy Department for almost a decade and the director of 2 centers at Harvard, and also chair of the board on physics and astronomy of the National Academies. I have a lot of leadership positions in my background that make me not pay too much attention to external pressure. I am trying to pursue science as it should be with an open mind, and that appears to appeal to the public.
And just a penultimate question, because I've got one from my program editor coming in. Ultimately, do you hope that there will be conclusive proof of alien life?
My hope is that in the coming decade, we will find evidence for alien intelligence, and that would teach us some modesty and perhaps convince us to change our priorities and to work together, because we are all part of the human species. We are all in the same boat. Of course, one way for us not to realize that we have siblings in the Milky Way galaxy is not to invest resources in searching for them. My point is that we should invest similar level of funding, billions of dollars, in the search for intelligent beings as we invest in the search for microbes. Because after all, we would derive a lot of inspiration from having a family member out there that we discover that is perhaps more accomplished than we are. It will inspire us to do better.
And Professor Loeb, are you a fan of the 3-body problem? And do you have sympathy for the dark forest theory?
The author of the 3-body problem did approach me, and Netflix asked me about my view, and I think it's an amazing book that opens up our imagination. I do believe that it's possible that aliens are not far away and they behave as if they're in a dark forest where they're worried about predators. And that's why they keep monitoring us. Unfortunately, we were transmitting signals without hesitation over the past 100 years. So everyone within 100 light years from Earth is aware of our existence. And the question is whether they will do anything about it if they see us as a threat. And of course, that's another reason to monitor interstellar objects.
Professor Avi Loeb, thank you so much today for your analysis. We really appreciate that. Thank you. Goodbye.